Okay, so we're continuing with interim test number 1. We're on question number 11, and we had students use circle, label, choose, use, where you circle the term. Remember that you circle just stopping at the number. The plus or the minus sign always go with the second term, or the next term. And you decide inside the bubble if there's one negative sign, it's a negative term. No negative signs, or two negative signs, it's a positive term. So we used circle, label, choose, use, and we wrote down whether the rule was same, add, keep, or different, subtract, bigger. And I noticed while I was doing this that if I'm going for the target of 12 minus negative 33, which is positive, adding these two together, it's positive 45. This is our goal we're going for, positive 45. I know that the ones that are different, subtract, bigger, forget about it. It's going to be too small. This one was a tricky one, but you have to keep the negative. It's same, add, keep, but the sign is negative. This is the only time where two negatives do not make a positive. Two negatives, I can get both fingers out here. Class, let's do it together. What do you get? Adding, 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 adding. What do you get? Bigger negative. Exactly. So you got a bigger negative, negative 45, so that guy is out. This one is positive 45. Yep, that's a good one. We're going to check it. This one is negative 21. This is one negative 21. So these are no good. I know for sure that the two answers I would pick are B and D. Now we're on number 12. Enter the value of, and I've got lots of decimals and I've got negatives. First thing I'm going to handle is the negatives. Class, how many negatives do you see in this question? Okay, I'm going to highlight them so you can see them better. There are 3. So if there are 3, is the answer going to be positive or negative? Okay, which one? Positive or negative?
Negative.
Negative. So I know the answer is negative. Now I'm not going to think about those negatives anymore. I am going to multiply the two numbers that are non-decimal places. 100 times 10. Class, what's 100 times 10?
1,000.
1,000. Good. Now I'm going to multiply 0.001 times 0.01. So I'm going to do that over here. 001 times... There will be no talking in the classroom at this time. Thank you very much. We're recording. Thank you. You contribute, and that's awesome. Class, what's 1 times 1? 1. Show me on your hands, please. Then you're going to say it out loud. Show me first. How many decimal places in this question? Show me. Everybody show. How many decimal places in this question? Okay, most of you have got it. There are 5. 1, 2, 3, 4, 5. 5 decimal places in the question. Make the answer have the same total decimal places. What do we fill in the spaces with? Zeros. So going around the 1 is 1. Then there's a 0 here, a 0 here, a 0 here, a 0 here. 4 zeros and a 1 make a total of 5 decimal places. That is what these two equal. Now I'm going to multiply this by 1,000. And then I will have covered all the numbers. I love multiplying by 1,000 because I can just bring down the 3 zeros. Easy peasy. I don't do a row of zeros wasting my time. I just bring them down. 1 times 1 is 1. And now I go back and count the decimal. Oh, sorry. And now I count the decimal places from above. So how many decimal places in the question now? Show me on your hands, please. Still 5? Yep, still 5. So this has 5 decimal places. I'm going to make the answer have 5. Start behind it. 1, 2, 3, 4. One more. What do I fill in the space with? 0. What is our final answer? 0.01. 0.01. Exactly. You can put an optional 0 in front, but 0.01 is it. Great. Next page. So we just have 2 more questions on this interim test. Question number 13. Given x and y are rational numbers, when x minus y is in absolute values, when does x minus y, the absolute value of x minus the absolute value of y, make it true? Given that x and y are rational numbers, first off we need to talk about rational. This is one of the words that you need to know. Are rational numbers just whole numbers? Yes or no? No, what's also rational besides whole numbers? Can negatives be rational numbers? Yes. Can fractions be rational numbers? Yes. The only things that are irrational, let's review. Irrational. I think of the funniest, most interesting number of all that has to do with curves. It's a Greek number. What is it?
8.
No. Has to do with anytime you calculate
3.
circle stuff. Yep. Pi. Pi is it. So pi is an irrational number. Now pi is spelled P-I. Pi is irrational. And the P here reminds me of the other things that are irrational. Patterns and non-perfect square roots. So those are the only irrational. So all the rest of the numbers you've ever dealt with are rational. Every number you've normally dealt with, except for pi. And if you see a pattern like it was 0.121121112, that's irrational. Or a non-perfect square root, like the square root of 3. That's irrational. But everything else is rational. So when is the absolute value of x minus y equal to the absolute value of x minus the absolute value of y? Okay, this is never true. This is always true. This is sometimes true. This is true when x and y have the same sign. Ooh, there you go. So those are the choices. Let's just plug in a couple of numbers. So throw out a number for x and throw out a number for y.
5.
Okay, x is going to equal 5, and y is going to equal what?
7.
Okay, 5 and 7. Okay, 5 minus 7 is going to be negative 2, absolute value, and that's going to equal 2. Now, if we plugged in the 5 here, absolute value of 5 is 5, minus the absolute value of 7 is 7. Oops, sorry, no lines. Five minus 7, does that equal 2? Class, what's 5 minus 7? Negative 2. So are these two equal? So this is what we write. We write an equal sign with a baby question mark, equal sign with the baby question mark, and down here we realize, nope, not equal. So we know that this is always true is out, because we just made sure it was false. This is never true. Is there ever a time when x and y could be subtracted and it could be the same? Let's try 5 and 3. Okay, so if we tried 5 minus 3, absolute value is going to equal 2. Does that equal 5 minus the absolute value of 3? Okay, what's 5 minus 3? 2. Here it does equal. So I want you to talk with your math mates right now. Which answer is true? We know that this is never true is out. So we're to these two choices. This is sometimes true, or this is true when x and y have the same sign. We know it is sometimes true, but you're supposed to give your best answer. I'm not even sure which choice they would pick. Both of these are true. So if it says, when is it true? Sometimes true is kind of like, not sure if that's a good question answer. Is it true when the x and the y have the same sign?
Yes.
Let's try it with negatives. What if it was negative 5 minus negative 3, absolute value? Negative 5 minus negative 3. Okay, that's where we're going to leave this one. Stop. Thanks, you guys.